At first, you have to open the gene expression data that you actually got from qPCR instrument, and then you have to open the LinRegPCR tool here. So this is the dashboard of the tool, and you have to import your data to that tool. How you can do this? So go to file section and then read from Excel, because you already opened the Excel file here, and here you can see the default option here. So the setting that you used last time, it'll be similar. So my one is Cybergreen method I used for these qPCR, and these are default here, and this book is the Excel file that is here already opened, and the sheet is the first one, so there's no any change of that. And what I can do, I will just show you how to actually go to step by step from now here. So you have to see the number, like you have to select the column and row. So this column, we started actually from column B, so I wrote B here, and then through column AP I wrote happy. So the row, so where the data actually starts from, so data starts from row 13, so I have to row, and then it goes through to 77, as you can see in these. So I wrote 77, and then just you have to click OK. You have to select this rotor gene as well. After clicking OK, these will be the first base dashboard on LinRegPCR. So all the samples and all the data that actually amplified, it will be showing like that. This is the typical qPCR plot. So now, after getting this plot, we have to click on the determine baseline. So after finishing all of the samples, they actually show each sample with their R information and efficiency. So as you can see, this is sample 1. So this is exactly same as the typical qPCR plot, and the R number is close to 1, which seems to be the data is reliable, and the PCR efficiency is 1.857. So any sample who gave the PCR efficiency more than 1.8 seems to be a better one, so it's useful for the next step. And you can check each and every samples going one after one about their R and PCR efficiency values. So after completing this task, all right, now we're just going to amplicon groups. So as I said that we have separate sample groups here. So you have to define which group, how many groups there, and which sample will be falling to which groups. So that's all I'll be doing. So I'm clicking in the naming options. So here, this is something default, no names. So the main thing starts from base groups, the first part of the sample name. So this is the sample name. So the grouping starts actually from the names here. So I will group from the first of this name, because I used this gap DH and the negative control and then other samples as well. So I'll select the first one, and then select from the front. Yeah, we'll be starting from the front, and then space. So how did I separate that? So as you can see that the this is separated by the symbol. So I'll just put this symbol there, separator. And then I'll click on extract application, amplicons, okay? So after that, it will be identifier names will be there, and then you'll also see how many groups there. So there are 2 groups and total 64 samples I analyzed here. So that's great. So now I will be exporting. So these this will be actually exporting to the same file that is open. You can do, or you can just create a new file. I'll be doing in the same file. And what information you need to export? So I'll be exporting the whole package here. So compact and complete. So every information you'll need for further analysis, you'll need this information. You'll need to select these two options there. All right, then the LinRegPCR job is done. So now we got the file with the gene expression comparative analysis data, and there you can see that each of the sample had their PCR efficiency and their group name, their threshold, and their mean PCR efficiency. So the mean actually calculated from that particular group, the average one, and the CQ value, so which value actually it will determine the amplification happens. Yeah, and also there are a lot of other informations which probably you may need to consider before proceeding to the next step. So now what you can do, you can just get these CQ values and also this efficiency, so to calculate your comparative gene expression. So that's the part that you can export this file to the Excel format, not the CSV format, because if you just keep the CSV format, then probably some of the tabs from this file may be lost. So that's why you have to, that's the first job, that you have to export this into the Excel file. So all the tabs are actually retained, and from these file you can use different methods like the double delta CT values to actually calculate the gene expression, comparing different samples from the negative controls or something, whatever actually is there. I used several methods in my analysis, so 3 different methods for gene expression analysis. So in my next video, I will show what these methods and how this gene expression is calculated to get a comparative relationship between samples. Great, thank you so much for staying with me, and appreciate your time. And I hope that you learn how to analyze this LinRegPCR to generate qPCR data for further analysis. And I'll take a leave then, and I hope that you enjoyed the video, and please subscribe if you just want to see the next video aligning. Thank you so much. Bye.